A pre-commit checklist is a structured list of security and quality checks that every developer must run, or that are automatically triggered, before any piece of code is officially committed to a shared version control repository such as Git. The purpose of this checklist is simple: catch problems as early as possible, before they travel downstream into a pipeline, a staging environment, or worse, a production deployment. You have already seen how pre-commit hooks work technically and how to configure a basic rule. Now the goal is to understand the full logic behind a comprehensive checklist, step by step, so that nothing is left to chance. Why a pre-commit checklist matters in DevSecOps. In a traditional development workflow, security checks happen late, often after the code has been merged, built, and sometimes even deployed. This is expensive in terms of time, effort, and risk. DevSecOps, and particularly the shift-left principle you studied earlier, demands that security enters the conversation at the very first moment a developer writes a line of code. The pre-commit stage is the earliest possible intervention point in the pipeline. A well-structured checklist at this stage acts as a personal security guardian for every developer, catching obvious mistakes before they become organizational problems. Think of it this way: fixing a hard-coded password in a developer's local environment takes 5 seconds. Fixing the same hard-coded password after it has been pushed to a public repository, indexed by search engines, and potentially exploited takes days of incident response, credential rotation, user notification, and reputational damage control. Step 1. Verify that no secrets or credentials are present in the code. The very first check on any pre-commit checklist must be a scan for secrets. Secrets include API keys, database passwords, private cryptographic keys, authentication tokens, and any other piece of sensitive data that should never appear in source code. Tools like TruffleHog, GitLeaks, or Detect Secrets are designed specifically for this purpose and can be integrated directly into a pre-commit hook. A concrete example: a developer working on a cloud integration accidentally leaves their AWS access key directly in a configuration file. For instance, writing AWS_access_key_id_wells Akios Foden 7 example directly in a Python script. Without a pre-commit secret scan, this key would be committed, pushed, and could be discovered within minutes by automated bots that scan public repositories. With a secret scanner in the checklist, the commit is blocked and the developer is immediately alerted. The checklist item for this step should explicitly state: run a secrets detection tool on all staged files and block the commit if any match is found. Step 2. Ensure no sensitive files are accidentally staged. Beyond credentials embedded in code, developers sometimes accidentally stage files that should never be committed. Environment files, such as NFS files containing database connection strings, private key files, with extensions like PEM or key, local configuration files, or IDE-specific directories. A well-configured gitignore file helps, but it is not enough on its own because developers can manually force add ignored files. The checklist must include a verification step that checks the list of staged files and flags any file whose name or extension matches a list of forbidden patterns. For example, any file named env, any file ending in PEM, key, or PFX, and any file located inside a folder named secrets or credentials should be flagged and the commit blocked pending review. Step 3. Run static code analysis on staged files. Static application security testing tools analyze source code without executing it, looking for known vulnerability patterns. At the pre-commit stage, you do not need to run a full project scan, only the files being staged for this particular commit. This keeps the check fast and relevant. For Python code, a tool like Bandit examines the code for issues such as the use of the insecure eval function, hard-coded passwords in string literals, SQL queries built by string concatenation, which leads to SQL injection vulnerabilities, or the use of outdated cryptographic functions like MD5 for password hashing. For JavaScript, tools like ESLint with security-focused plugins can catch similar issues. A concrete example: a developer writes a database query as follows: query equals select from users where username equals plus user underscore input. A static analysis tool flags this immediately as a potential SQL injection point, because the user input is concatenated directly into the query string without any sanitization or parameterization. The commit is blocked, and the developer is asked to use a parameterized query instead. For instance, cursor.execute select from users where username equals user underscore input. The checklist item here is: run static analysis on all staged source code files and block the commit if any high severity or critical finding is reported. Step 4. Check for outdated or vulnerable dependencies. Modern applications depend heavily on third-party libraries and packages. These dependencies can contain known vulnerabilities that are publicly documented in databases such as the National Vulnerability Database. Software composition analysis tools compare your declared dependencies against these databases and report any package with a known security issue. At the pre-commit stage, the checklist should trigger a dependency check whenever a dependency manifest file is among the staged files. Dependency manifest files are files like requirements.txt in Python projects, package.json in Node.js projects, palm.xml in Java projects, or gemfile in Ruby projects. Tools like Safety for Python or npm audit for Node.js can be run automatically. A concrete example. A developer adds the library flask == 0.12.2 to a requirements.txt file. A dependency scanner immediately flags this version as vulnerable to a known session cookie security flaw that was patched in later versions. The commit is blocked and the developer is directed to upgrade to a safe version. Step 5. Enforce code formatting and linting standards. Although not strictly a security check, enforcing code style and linting at the pre-commit stage contributes to overall code quality and makes security reviews easier. Poorly formatted or inconsistently structured code is harder to audit, which means security issues are more likely to be missed during code review. Tools like Black or Flake 8 for Python, or Prettier for JavaScript, can be run automatically on staged files. This step also catches simple logical errors, for example, unreachable code blocks, unused imports that might indicate dead or experimental code that should not be shipped, and missing error handling around sensitive operations like file reads or network calls. Step 6. Validate configuration files for common misconfigurations. Configuration files, whether they are YAML pipelines, Docker file definitions, infrastructure as code templates, or web server configuration files, are frequent sources of security misconfigurations. At the pre-commit stage, any staged configuration file should be validated against a set of security rules. For example, a Docker file that runs the application as the root user should trigger a warning, because running containers as root is a well-known security risk. A YAML pipeline file that disables certificate verification or uses an insecure communication protocol should also be flagged. Tools like Hadalint for Docker files or Checkoff for infrastructure as code templates can be integrated into the checklist for this purpose. A concrete example: a developer writes a Docker file containing the line user root followed by the application startup command. Hadalint flags this, explaining that processes inside the container should run as a non-root user to limit the impact of a potential container escape vulnerability. Step 7. Confirm commit message format. A well-structured commit message is not just a matter of team discipline, it is a traceability tool. In a secure development environment, every change must be traceable. Why was this change made, by whom, and does it relate to a security ticket or a known vulnerability remediation? A checklist item that enforces a commit message format, for example, requiring a reference to a ticket number or a change category like fix, feat, or security, ensures that the audit trail is always complete. Example of a well-formed commit message: security, remove hard-coded API key from config.py, resolves ticket SEC 142. This message immediately communicates the nature of the change and links it to a trackable item in the project management system. Step 8. Perform a final manual review reminder. Even with all automated checks in place, the checklist should end with a human-facing reminder. Automated tools cannot catch every issue. They miss business logic flaws, context-dependent authorization problems, and subtle cryptographic misuse that requires a human expert to identify. The final step of the checklist is a prompt that asks the developer to confirm they have personally reviewed the staged changes, and that they are confident no sensitive data or obvious security flaw has been introduced. This is not bureaucracy. It is a deliberate moment of accountability. The act of pausing to answer this confirmation prompt, even for a few seconds, has been shown to catch issues that automation missed, because it forces the developer to think actively about what they are committing rather than treating the commit as a purely mechanical act. Putting the checklist together in practice. A complete pre-commit checklist, in order, looks like this. Scan all staged files for secrets and credentials. Verify that no forbidden file types or sensitive configuration files are being staged. Run static code analysis on all staged source files and block on high or critical findings. If a dependency manifest is staged, run a dependency vulnerability scan and block on known vulnerabilities above a defined severity threshold. Run code formatting and linting tools and enforce compliance. Validate any staged configuration files against security rules. Enforce the required commit message format. Display a human confirmation prompt reminding the developer to perform a final personal review. This checklist should be implemented using a pre-commit framework, for instance, the pre-commit open-source framework for Python-based projects, so that each step runs automatically and in order every time a developer runs git commit. If any step fails, the entire commit is blocked until the issue is resolved. This is a hard gate, not a soft suggestion. Important integration note: the pre-commit checklist does not replace later pipeline stages. Static application security testing tools run at the pre-commit stage are lightweight and fast but not exhaustive. Dynamic application security testing, full dependency audits, and container image scanning happen further along the pipeline. The pre-commit checklist is the first layer of a defense in-depth strategy, necessary, but never sufficient on its own. Common mistakes to avoid. Several mistakes are frequently observed when teams set up pre-commit checklists for the first time. The first is making the checklist too slow. If checks take more than 30 seconds, developers will find ways to bypass them using the no-verify flag in Git. Keep checks fast by limiting them to staged files only and by choosing lightweight tools. The second mistake is setting severity thresholds too low, causing an overwhelming number of false positives. If every commit is blocked by dozens of low-priority warnings, developers lose trust in the tool and start ignoring or bypassing it. Configure tools to block only on high and critical severity findings, and route lower severity findings to a separate reporting channel. The third mistake is failing to version control the checklist configuration itself. The pre-commit configuration file must be stored in the repository alongside the application code, so that every developer on the team uses the same rules and so that changes to the checklist are subject to code review just like any other change. Summary: a pre-commit checklist is a structured, automated, and enforceable sequence of security and quality gates applied at the moment a developer attempts to commit code. It covers secrets detection, file type validation, static code analysis, dependency scanning, configuration validation, code quality enforcement, commit message formatting, and a final human review step. When properly implemented, it is the most cost-effective security investment in the entire pipeline, because it catches vulnerabilities at the point where fixing them requires the least effort and causes the least disruption.